I'm like
Okay, so here's problem number 2. My first step again is going to be what?
To H naught
An H1. Okay, so everybody, what's my H naught?
rho equals 0.
Rho equals 0. Everybody, what's my H1?
does not equal
Rho
0.
does not equal 0.
Great. Step 2.
Draw a picture.
Draw a picture. Yep.
Wow.
Here's my 0. These are my -1 and my +1. I need to figure out what my critical values. So let's see, I've got 7 items. So that means my degrees of freedom is 7 minus 2, which is 5. My alpha is
0.05.
Is it 0.05?
Yes.
Yeah. Okay, so then I'm going to grab out my handy dandy table and look and see. Okay, 0.05. I get 0.754.
Yes, sir.
So you guys start?
Ma'am.
Yep. 0.754.
Yeah, buddy.
Negative 0.754 and positive 0.754. And then I'm going to say, oh look, I'm going to make this one my list 1. And this one's my list 2. And I'm going to do stat, test, then reg t-test. Oops, t-test of L1, comma L2. And I'm going to end up with R equals, what do you guys get? 0.445? Great, and then I'm going to throw that in here. 0.445. So, what do you guys think? Step 4.
Do not reject.
Yeah, do not reject. H naught, which means it's not aligned. Everybody on board with that?
Yeah.
This is the important, tricky part for you guys to understand. If you do not reject H naught, then it's not aligned. Everybody good? Yeah? Exactly, it's all over the place. It's not in a nice sort of line-like form. So, step 5.
There is not enough evidence to support the claim of correlation between size and revenue from casinos in Atlantic City.
See that slower. Not enough evidence to support.
The claim
Uh-huh.
of correlation between size and
Casino
revenue.
size.
Casino size and revenue.
Size and revenue. Okay, so don't get caught up on that bottom part that we gave you of the quiz, about the 17, whatever part. We'll talk about that in a minute. All right, so then my question to you is this. Oh, there's no question. Okay, good. So next we're going to talk about regression. Everybody has their notes, yeah? Going through that, talking about the final exam. You are scheduled to take your final exam at 5:30, and it's an hour and 50 minutes off. I would like to propose that you guys start your final exam at 5:15. That way I can give you guys a full 2 hours. I can give you that 10 minutes bonus time at the end if you need it.
Yeah, we could do that.
Okay. Is everybody good with starting at 5:15?
Yeah.
Okay. So we'll go ahead and do that. All right. The regression line. What am I reading? Zach, go ahead and read. Put that away.
The regression line, the line of best fit or least square line, is the straight line that best fits the scatter plot of the data.
Right. So here's kind of where the x bar, comma y bar is between the average x and the average y. And there's a whole bunch of lines you can draw going through that point. Everybody kind of follow what I'm saying? If you find a line that best fits the data, then that is the regression line. You might say, well, how do we find that? That's a great question. This is how we find it. This is how I had to find it back when I was in school.
Oh, no, that looks terrible.
Yeah, so you draw a line, you figure you find the equation of a line, and then you calculate how far, straight up or down, to the line each point is. You take all those distances, you square them, and you add them up. The line that has the smallest sum, when you square all the differences and add them up, is your line of best fit, your regression line.
So like before calculators, did it take like 8 hours for you guys to do this? Like one problem?
And I think the thing about it too is that you can you can find out, well, it's here, and you can find it here, and then you can kind of figure out, oh, I'm getting closer, right? You either get closer, as you go up or down, you get closer or you get further away, right? So you
Yeah.
have to kind of, it helps you a little bit.
So the
Yeah,
test was
and
like
then-
2 questions? 2 question test?
I think they would take people probably days to find this sort of stuff, back in the old days. All right, so this is important. You notice it's all in color, right? So stuff in color is the stuff that's really important. So this is super important. How about Edwin? Go ahead.
Regression line. This line is used to predict the values of y for a given x, only used when there is a correlation/relationship.
Right. So here's the thing. If I have a bunch of jumbled numbers, it will give me a line that reduces that thing the best. But if my data is not represented by a line, it doesn't make sense to use a line to predict where things are going to be. Do you guys see what I'm saying? So if your line is if your data is sort of line-like, and you come up with this line, then it makes total sense to use a line to predict. Keep going.
When r is not significantly different from 0, the best predictor of y is the mean of the data values of y. If no line, use the average y.
Right? So for example, say shoe size and the hours of television someone watches a week. Do you guys think those are correlated?
No.
Okay, probably not. Right, so but say we come up with some sort of regression line that kind of looks like this. So what do you think is the best predictor of someone with a size 12 shoe? I want to know typically how many hours of sleep hours of TV someone who has a size 12 shoe watches. Should I just follow that line out and say, oh, they must watch 23 hours of TV? Or is it better for me to take the average number of hours of TV someone watches a week?
Yeah, do an average.
Take the average. You guys see what I'm saying?
Yeah.
When there's no correlation, in other words, when you have not rejected H naught, no rejecting H naught means no correlation, not a line. Just use the average. You guys see what I'm saying? So if I want to guess what if I give it X, then and I want to say what's the Y that goes with that X, it would just probably be the best guess is the average Y if there's no correlation. So you guys are following this. So in other words, if I want to say, okay, someone with a size 3 shoe, how much TV would they watch? Well, the average number of television that person watches is probably my best guess. Good? Okay. Great. So here, this is when you reject H naught, and this is when you do not reject H naught. This is not a line. This is a line.
You sure you haven't got that backwards?
Oh, I do have it backwards. Thank you so much. I'm so glad you're there. Yeah, reject H naught. It is a line. Sorry.
Because
Yeah, I
H naught
thought,
means
yeah.
Yep. So sorry. Yeah. Do not reject H naught. Not a line. Yep.
I was like, do I not know anything that we've been
Right.
doing this whole time?
Right. I'm so sorry. Yeah, my head's just spinning. All right. So yes. So reject H naught. That means it is a line. If you do not reject H naught, it's not a line. Good. Good?
Yep.
Okay. Yeah, I had him switch. This is H1.
Life gets wild sometimes.
Yep. And this is H naught. When you like H naught, do not reject H naught, it's not a line. When you like H1, it is a line, reject H naught. Good. So how do I find the regression line? It's this big, long calculated formula, which actually, honestly, we were glad to have that. Because having that, at least we could find it and it was all findable, right? A lot better than having to take all the squares and all the differences and square them and add them up. Where y equals a plus bx, right? A is the intercept and b is the slope of the line. So you guys are all familiar with stuff like y equals mx plus b. Who's heard of y equals mx plus b? All right, so this is the same thing. The only difference is that this is just switching it's switching it around. So we're saying y equals b plus mx. You could write it either way. If you prefer to write it the other way, you can write it that way. But it's basically your standard sort of equation of a line. Y equals some slope times x plus b. What's your intercept?
May I just say some of the reasoning behind this?
Yeah, good.
Essentially, it means that you can have like y equals a plus bx plus cx squared plus bx cubed, and you can just stop wherever. And then that you just don't need to write any further. But since we write left to right, kind of chopping off at the beginning, it kind of doesn't really.
Yeah, so what he's saying is that it makes sense to start with the main number first and then go with your x, and then you could go x squared if you had x squared and so forth. But yeah, so you can do it, this is typically how we write it. We're all good with this. If you prefer to write the other way, if you feel more comfortable, that's fine too. The nice thing about using a TI calculator is that you already know how to define Lindbergh's t-test. It gives you a and b right in the beginning. And it gives you the formula y equals a plus bx in case you forget that. So if I go back to my calculator and look at it, oops, I took stuff out of there, and say I put things in. Like say I put in 12 and 8 and 14 and 6. And I go over here, and I put in 6 and 5 and 8 and 2. And then I go to stat, test, Lindbergh t-test. It will give me, see what it says y equals a plus bx up there? It gives us that formula. And then it tells me what a is, and it tells me what b is. So here, it'd be y equals negative 1.25 plus 0.65x. That would be my equation of my regression line. My line of best fit. Okay? And then if I keep going down, it gives me r. And it gives me r squared. R squared is roughly the percent of data that can be described by the line that you've created. So it's kind of neat. The percent of data that kind of fits that line very well. Okay.
There was that. I think it was like the percentage of variation. I thought it's
Okay.
that is explained by the line.
The percent of what?
The variation in y values that is explained by the line, and then there's obviously some noise.
Yeah. I think people are good with just the general sort of, we'll keep it super simple, right?
Okay.
So you kind of just think of it that way. That's kind of how the high school books describe it, which I think is a nice simplified version of explanation. We'll keep it simple. Okay. So everybody good with finding A and B and knowing that this is your formula you're going to use, y equals a plus bx. Here's your A, and that gives you your B. Okay. So again, remember x is your explanatory variable. It's an independent variable. Y is your response variable, your dependent variable. And this is the relationship between x and y. And they call it y prime, but it's a y. And I could give you either one of them. So, say you have, it's a equation of a line. If I have this, and I gave you x, could you find the y that goes with that x?
Yeah.
If I gave you y, if I said y is 13, when y is 13, can you find the x that goes with that?
Yeah.
Right, everybody on board? I could give you either one. So when y is 13, this becomes 13 equals 4.2x plus 7.1. What's the first thing I'm going to do? Yeah, subtract 7.1 from both sides. And then you're going to end up with 5.9 equals 4.2x. And then what's the next thing I do?
Divide by 4.2.
Divide by 4.2. So then you end up with x equals 5.9 divided by 4.2. 1.4. Good? Everybody on board?
Yeah.
And get into that in a little bit more in an example. Here is a warning. Jeff, want to read the warning for us?
Use the regression equation for predictions only if the linear correlation coefficient R indicates that there is a linear correlation between the two variables, and if the graph of the regression line on the scatter plot confirms that the regression line fits the point reasonably well.
Good. Right, so again, you can only use regression line if your data forms a line, if it's similar to a line. In other words, if you reject H naught, that's the only time you can use this. You only use regression line when you reject H naught. If you don't reject H naught, you gotta just use the average. You have to use Y bar and X bar. Just use the averages to predict. Oh, and also, if the scatter plot confirms the regression line fits the points reasonably well, which we're going to talk about in just a few slides. Also, so data should not go too much beyond the scope of the available data. If you predict too far beyond the scope, then weird things start happening, right? If you try to predict, like if I try to predict what's gonna happen, like cell phone growth, cell phones are growing a lot, right? If I look over the last 10 years or 20 years, how much they've grown, is that a good, do you think I could use that data to do a good job of predicting what's up, how many people are going to be using cell phones in the year 2050, over 100 years from now? No, they probably didn't have cell phones anymore. They'll have something even more advanced. I don't know. They'll have glasses they put on.
Yeah,
or,
we'll
I don't know,
check
something-
their eye,
yeah,
you're like-
I mean, it'll be totally great. You know what I'm saying? So you got to kind of stay within. You can't go too far beyond your data. If you have 50 years of data, you can't go 200 years out. Good. All right. Also, if your data is not correlated, the best predicted value is its sample mean. Good. Here's a couple more. Here's another diagram about this. So here's a strategy. If you reject H naught, so reject H naught, and it is a line, and you use this guy right there. Watch, you won't use that one. You'll use y equals a plus bx. Good? Martin said nothing, so I guess I'm good.
I just said it over you, but.
And said, if the regression equation is not good, then you do not reject H naught. It's not a line. So then you'd use y equals y bar, if you're trying to guess what y is, or if you're trying to guess what x is, you'd use just the average x. Yeah.
So is our claim always H1?
Yeah. For these ones, pretty much our claim is always going to be H1. You wouldn't say, I claim there's no correlation between these two. You pretty much would say, I think there's a correlation between them. All right. So you'll see how this one sort of has a positive correlation, right? They're correlated, they're kind of going up. And this one here has no correlation whatsoever, right? So the best predictor is to just use the average. The average y is your best predictor. No matter what the x is, just guess that the best prediction is just whatever the average is. And then here, see how the data is kind of going down, you can use the correlation, the linear regression line to predict it going down. Make sense? Okay so far? Okay. Yeah, I don't know if I need to say this again. Oh, I talked this in already. Okay, the other thing. Right, so if you kind of look at it, I think the only thing between these two things is I just changed a couple of stuff. I think I just removed a couple of points. I just removed these 2 points, and to only change between the top and the bottom. And just removing those 2 points made, even though the picture looks pretty the same, it made the line wiggle. Do you guys see how the line changed? So, do you think a good predictor, it doesn't make sense for this to predict something way out here or way out here if you just from moving a couple points. It's still like pretty much the same. So that's why when your data is not correlated, can you guys kind of agree how both these pictures look like the data is completely not correlated?
Mm-hmm. Yep.
Right? And they're going to give me wildly different results. Not wildly, but quite different results. Just use the average. That little red line should be right here. Should be right there. That's exactly where it should stay. It should just stay right there, no matter what. Just use the average y to do all your predictions. Because again, if someone has a size 12 shoe, you're not going to say, oh, I think they watch 30 hours of TV. Right? Just the average hours of TV someone watches, 12 hours. Good?
Yep.
Okay. What is the average hours of TV people watch a week, do you think?
I don't know, your phone's probably way more than TV nowadays.
Oh yeah, you have an app on your phone that tells you, well if you have an iPhone, it tells you how much you spend a day on your phone.
On your iPhone?
Yeah, I put a lock on mine as of recently.
That's crazy.
Yeah,
Right.
that scared me. I didn't want to see
and then,
that.
this is interesting.
Pretty much.
So, this is, you guys, let's stay a little focused because I don't want to go over time with you guys. I would like to get out of here on time.
Can do.
So,
44 times.
this is an interesting thing how this illustrates just how important it is to do a scatter plot of your data. Because all 4 of these have the same, I believe that's the same correlation coefficient R, and they have the same,
I actually suggested this. They have the same x bar and y bar. They have the same s sub x and s sub y, so standard deviations. They have the same regression line and the same correlation coefficient.
Right.
Yet are very different.
So the 2 things you guys would use would be the same correlation coefficient R, and they have the same linear regression line. So y equals mx plus b. They have the same, y equals a plus bx. But see how the first one looks like you should use it, and it kind of follows. Mm-hmm. So the second one's kind of curved. The data is totally curved.
Looks like a parabola.
It does look like a parabola. So you totally should not be using linear regression line for that. Do you guys kind of follow? Mm-hmm. This one, do you guys see this little guy?
The Outlander.
Yeah, the ladder guy. So this one looks like it just should go like this somehow. This one, if you remove him, and the data kind of go totally like that. You know what I'm saying? And this one, another outlier. So your data should kind of go more like that. Do you guys kind of following?
Yeah.
So that's why that graphing matters. Because you have just one little tiny weird guy out there. It'll totally change your data and what your, it'll say, this by itself would just be an R of 1. Do you guys kind of follow? But then you throw in one little outlier and your R's drops your R. So it still thinks, well, it's kind of like a line because your data is almost perfect line if you ignore that one. And then it throws off this linear regression line. So, you know what I'm saying? A little bit, yeah. It's totally, yeah. So that's why that scatter plot is a critical part to kind of take a look at it and see. And the nice thing too is actually, you can do a good scatter plot just like this. Stat plot. Second, stat plot. L1, L2. I need you to go down to it, hit enter, and then go to on.
That's great.
Yeah, and then it says your X is L1, your Y is L2. And let's use, yes, circles are good. And then you just plot it. Oh, and then you just graph it. There should be
Basically
one
no
over
fit.
here. Yeah. Sorry, zoom 9. Where's my zoom? Zoom 9. There they are. So it's kind of cool that this will do that for you too. If it was super important, we'd do it more, but you're only gonna have like 4 or 5 to graph. It's not important to spend more time on that. It's really good, I think. Okay. So here, we're going to do an example. This is the bottom of your page. I think the bottom of your page. We're going to do, we're going to use alpha equals 0.05 in the PPMC table, find the coefficient of the regression line. So first, go ahead and put this into your X. This is your L1. This is your L2. Throw them in there. So go to your calculator. Everybody know where we are? We're at the bottom of that page. Example. Put your data in. I know, but we got to do others. We're going to do other stuff. Oh. Yeah, you got to find your A and your B. So put them in. Use your, give us your calculator.
Oh, this one right here. I might. I already did this one.
I have a question.
Yeah, hold on a second, I got nothing wrong. These are not-
Did I already do this one?
You done? You put them in? You have these in-
No, what do you do? Did I do the wrong things? No,
Sorry, do you have questions?
oh.
Yeah, so just out of curiosity, if you looked at these numbers, wouldn't you kind of get an idea if like you had something like this, you know that this is it's not gonna be a straight line because of the numbers, or you can't really gauge it that way?
Sometimes you can, sometimes you can't. Because this one is
This-
large and that
right,
one's small, then
small.
you can kind of say, yeah, they're long.
Okay.
Yeah.
So we're not doing this one, Dave? I'll have to on
We're doing the example.
Ah, son of a.
So cars, 63, 29, 20.8, that's what we're doing. And then after you get your data in, find your R, find your A, and find your B. Find your Y equals blank, blank, blank. And double check the numbers when you put them in your list, because if you mistype it, everything in chapters 10 and 11 is going to be on the calculator, which means if you mistype stuff, you are SOL. You got to double check your data when you put them in lists, because if you mess that up, you'd be totally wrong and you have no idea. So stat, test, Lin-Reg t-test, already on board with that? Okay, so it looks like we have y equals, what's my a? 0.396. And then what's my b?
0.106.
Minus 0.106x. And go three or four decimal places, or sig figs on these guys. Okay, now, what's my r? Go down to r, 0.981, 982, 982.
Yeah, 0.9.
I don't know, I guess we're not drawing and doing all that stuff, we're just doing this.
Yeah, just in this part here. And then I'm going to look at, maybe I'll graph it. Let's go ahead and graph it. So, again, if you guys want to know how to get to the graphing, go to second stat plot right up here, right up directly above the second key, second stat plot. And you guys see number 1? So hit enter.
Even if it says off?
Yep. Hit enter, and then you can turn it on. So go to where we're blinking on and hit enter so it's on.
Okay.
Because see over here, if I hit it, it's on off.
Yeah.
I go over to on, and I hit enter, now it's clicking on
Got it.
on. And then this type should be the first one, the little scatter plot thing. And then list 1, list 2, and a circle's good, or you can use the plus sign. Just the little dots are hard to see, so I wouldn't do that one. I do only zoom.
Okay.
And then hit zoom 9. Zoom, which is in the middle right here. Zoom 9 makes it really easy. I'll graph it for you.
Oh, look at it, so cute.
Yeah. So you guys have something like that?
Uh-huh.
So that looks pretty good, right? So there's not any crazy outliers there.
Did you know that this is what video games look like?
Did I turn this off? Oh, it's still on? Okay, good. All right.
I have a question.
Yes.
My calculator is
You guys play. What was that?
weird.
Spazzing out.
Oh. We'll have to look at it later. Yeah.
So, for this question,
Oh, yeah.
you don't have to draw a picture or nothing? Oh, like this?
Right. No. Yeah. So then we should draw a picture. So I need to find my critical values. So right now, I just want you to get. We're not going to do the whole test. We're just going to look at what we want to use. So here's our picture. What's my critical value? Alpha's 0.05. Degrees of freedom 4. What did you guys get? 0.8.
Yeah.
0.811.
Yeah.
And where am I? 0.9. So I'm right here.
So you reject it.
Am I? Yeah, I'm rejecting H naught.
Yeah, there's a line.
Yeah, it is a line. It's a line. It's a line. Okay, which means I can use this line. Yeah, I can use my y equals 0.396 plus 0.106x. Does everybody understand why we can use it? Yes or no? Talk to your neighbors. Why can we use that top line, our linear regression line? Yeah, because rejected H naught, it's a line. Good?
Yeah.
All right, so let's go ahead. We're trying to predict. What are we trying to predict?
What? Why?
So, everybody look at the example. It says, approximate the income for 40,000 cars. Everybody on board? I need you guys with me. All eyes here. Approximate the income for 40,000 cars. Is 40,000 cars, is that my X or my Y?
X.
It's my X. You guys see that? So, X is cars in 10,000s. So, 40,000 cars means how many 10,000 cars?
4.
4. So, my X is 4. Everybody follow that?
Ooh.
Everybody good?
Yep.
So, X is 4. So, 40,000 cars. X equals 4. And saying, what's my income? Which one's income, X or Y? Y. So what's my income when x is 4? That's what it's asking me. So it means that what's y when x is 4? So my y is 0.396 plus 0.106 times what?
4.
4.
Fuck.
Everybody good with that? So I'm going to do this, and I'm going to end up with 0.396 plus
Oh my god.
0.424, which is 0.820. 0.820. Which is pretty good. $820 million. Everybody on board? Now, if my data was not aligned, then to predict my income, I would just use y bar, the average y. I would take all these y's and average them.
Wait,
How do I, I'm sorry?
can you say that one more time?
To get
If I didn't have a line, if I did not reject H naught, my data was not aligned, then to predict my income, my y, I would take all the y's and average them. The nice thing is, they're already sitting in a list. Can I find the list, average of a list really easily?
Yeah.
Yeah, 1 bar stats or 2 bar stats, either one. Since I have an x and a y, I could do it like this. Do you guys want to look at 2 bar stats? Stat, calc, 2 bar stats, since I have an x and a y. I would do second L1, comma, second L2. And it's going to give me my x's, but I don't care about my average x. I want my average y. You guys see that right there? Y bar equals 3.117. Yeah? Okay. So that's what I would use if there was no correlation. Okay. Great. So you guys do the problem right below that, lab problem number 5. Do lab problem 5.